Stan Jabalisco here to discuss a very simple concept in regards to field effect transistors, and then to ask a rather esoteric question. This material, field effect transistors, is covered in my book Teach Yourself Electricity and Electronics, 5th edition, a cover photograph of which you see right here. This is actually the preview page from the Amazon.com website for this book, which I will provide as a link in the description of this video. But what I'd like to do here now is go to the Long Wave Ranch in Cody, Wyoming for a moment, and then the Tranya, as it were, let the listener understand the substance of the issue. This is figure 23-1 from that book, showing the structural concept of an N-channel junction field effect transistor. The channel is of N-type semiconductor material. That's where the term N-channel comes from. The substrate is of P-type. That substrate is like the foundation on which the device is fabricated, and the gate, or the control electrode, is of P-type material. In the P-channel device, everything's just reversed. And over here on the right, this is figure 23-2. You'll learn all about this if you get a hold of that book. That's what I'm trying to encourage you to do on the side. Get a hold of that book, Teach Yourself Electricity and Electronics, 5th edition. Maybe someday I'll come out with another edition, but the material and the information on this subject will remain the same. Some things never change, eh? The way that a field effect transistor works is also described in this book. Source, gate, drain, charge carriers flow through. You bias the gate in a certain way, that is, you apply a certain voltage to the gate. It narrows that channel. If the voltage on the gate gets great enough, it will pinch the channel off and no charge carriers can flow. It operates very much like a vacuum tube. This is figure 23-3 in that same book, Teach Yourself Electricity and Electronics, 5th edition. Now my question is this. It's a question that someone emailed me, and I think it's a very good question. In a practical circuit, can you reverse the source and the drain and still have the device work? So you would simply connect the drain where the source would normally go in the circuit, and the source where the drain would normally go. Charge carriers, as figure 23-3 shows, flow through a continuous channel from source to drain. Could you just reverse the device and expect it to still work? I would be inclined to say maybe sometimes, but I don't know if you can always do it, because these diagrams, figure 23-2 and 23-1, are not literal constructional drawings. They are illustrative or functional constructive drawings. It could be that the device is really not symmetrical, that maybe the gate is closer to the source or closer to the drain, or the channel is not symmetrical. So if any of you know the answer to this question, please leave it as a comment in this video. I will leave comments open for this video, and again, I will also provide in the description of this video a link to the Amazon.com page for this book, and encourage you to get a copy, preferably a legitimate copy. Stan Jabalisco, signing off for now, daydreaming again at the Long Wave Ranch, where I someday hope to do long wave radio experiments. That's where the name comes from, near Cody, Wyoming, United States of America. But actually right now I'm making this video in the Black Hills, where I live. Until next time, have a good night. So long.